In this lecture, we're going to take a look at some of the factors you need to consider when you're deploying a wireless network. So what we're going to do in this lecture is we're going to talk about site surveys, speed and distance requirements, signal degradation and interference, wireless access point placement and channel selection, antenna types, and network security considerations. So let's go ahead and let's jump into it and let's talk about site surveys on the next slide. So one of the first things that you should do when you're looking to deploy a wireless network is to perform a site survey. And there's a caveat to site surveys. They're really only applicable to businesses, and I would say enterprise grade networks in medium to large businesses, because in a small business where it's a small suite and in a home environment, you don't have to go through the hassle of walking through and performing all the steps listed here on the slide, because you can simply just get a SOHO device or get mesh wireless and it's going to do the job just fine. But when you're looking to set up a larger wireless network, it's important that you go through these steps. So number one, you're going to want to go through and analyze the physical site via the blueprints. Take a look at the building blueprints, and that's going to allow you to get an idea of where you need to put everything. Then after that, perform a physical walkthrough of the building. Again, that's going to build on your analysis of the blueprints to better understand where you need to put everything. And then thirdly, perform a survey with a wireless survey tool. And we're going to take a look at what that looks like on the next slide. So a wireless survey tool is specialized software that allows us to perform wireless network analysis and optimization. What you see here on the screen is called a heat map. And it's a heat map that allows us to optimize the design of a wireless network. So for example, with this tool, what you're going to be able to see is you're going to be able to see where all the wireless access points are. And I'm just going to put arrows at some of them on here so you can see where they are. And where it shows green, that means there's a good signal. Where it gets darker, it means the signal is getting worse and worse. So ideally in the office space, you want it all to be green. And then outside of the office space, you don't care. And in some instances, you don't want your signal to go outside of the office space. So how does this help us? So number one, it can allow us to discover existing wireless networks. So for example, let's say that we're an IT consulting firm and a company has brought us in to improve their wireless network. We can take this software and we can analyze where all the current wireless access points are and also take a look at the strength of them. Then we can take that and we can set up some temporary new wireless access points and look to optimize them with channel selection and proper antenna type and have the most efficient design for our client. So that's where these come into play. It allows us to set up how we think everything needs to be designed and allows it to be as efficient as possible. So that's the purpose of a wireless survey tool. The next thing that we need to consider is our speed and distance requirements. So with any network, speed and distance is going to be important, and especially with wireless, distance is really important. So you need to ask a couple of important questions. Number one, what speeds does your wireless network need to support? So is it okay with 802.11n with 600 megabits per second? Or do we need to be up into the gigabit speeds with 802.11ac or 802.11ax? Number two, how many concurrent users are we going to have on the wireless network? Because as we know, 802.11n only supports one user communicating at a time, because remember, that is single user MIMO. Not until we get to 802.11ac and 802.11ax do we support multiple users communicating at once on a wireless network. And then number three, what about backwards compatibility? What are those requirements? Now you're going to notice that I only included 802.11n, AC, and AX. I didn't include any of the older standards, well, because people really aren't going to be using the older standards anymore. However, if you do need to make that a consideration, definitely do so. And then in terms of the distance and signal degradation and interference, one of the main things that we need to think about, and we'll talk about it further on the next slide, is the level of signal degradation and interference within a building. So we need to look at the approximate indoor range and then put into consideration how the signal will degrade based upon the environment and also any interference that's also going to inhibit the wireless network, and take a look at which standard is going to suit our needs the most. So if we take a look at this, you're going to notice that with 802.11n, the indoor distance is approximately 70 meters, whereas with 802.11ac, we're down to 35 meters, and then 802.11ax, we're down to 30 meters. Now, if you have a lot of money, meaning you have an appropriate budget to purchase a lot of wireless access points, this may not be an issue. But if you're on a tighter budget, then you may need to opt for slower speeds so you can stretch out the range for each individual wireless access point. So that's where speed and distance requirement comes into play, as well as signal degradation and interference. But we're going to talk about signal degradation and interference further on the next slide. So when it comes to wireless networks, signal degradation and interference is a huge issue we need to consider, because unlike with a wired network where everything goes through the wire, with wireless it's going through the air. And in a simple building where we don't have a lot of equipment, the walls themselves are going to be a way in which we degrade our signal. And then if we're in an environment where there's further interference, such as anything on the 2.4 gigahertz spectrum, or maybe we're in a manufacturing plant, or we're setting up a campus where we need to set up Wi-Fi outside, where there's natural interference such as trees and so forth, all that needs to be considered. And it all comes down to an important point, that advertised distances are rarely real-world distances. So just because a manufacturer puts it on paper as marketing material, in the real world, the odds of you seeing those advertised distances is going to be next to none. And the weaker the signal, then the less reliable the network connection is going to be, and the slower the effective data rate is going to be as well. So some things to think about. Think about your walls. Think about how the walls are constructed. So for example, down here we have a simple wall with metal framing. Is it metal framing? Is it sheetrocked? Is it going to be concrete? Because airwaves are going to be affected differently based upon the type of wall. If you're expanding your network out into a campus where it's outside, are there trees or bushes or other buildings that are potentially going to degrade your signal? And then are you in an environment where there's going to be interference from the 2.4 gigahertz spectrum, such as Bluetooth devices or phones or microwaves? And then spread it out even further. Are you in some sort of a manufacturing plant where there's potentially even further interference? And then lastly, are you in an area where there's potential channel interference as well? So let's say that you're in a business park, or let's say, for example, just in a home environment in an apartment building. There's going to be a lot of people with wireless access points, so we need to make sure that our channel isn't overlapping and interfering with somebody else's. But again, that applies both in a residential environment, but also in a business park environment. So we need to take all this into consideration, and that's where our site surveys come into play, and setting up temporary wireless access points and testing it out, because we can't really take this into consideration until we test it. So that's the issue of signal degradation and interference. So now let's talk about and revisit antenna types. So we've already gone over this, so I'll keep it short. We know that there are two different types. There's omnidirectional and there's unidirectional. Omnidirectional is when we're going to send the airwaves in all directions, and those are commonly going to be ceiling mounted in a business environment, or for example, in a coffee shop. And then there's unidirectional if you want it to go in one direction. That could be point to point from building to building, or it could just be on the edge of the building where we want the signal to only go inside the building. And remember, in terms of the strength, it's measured in dBi, and the higher the dBi, the further the distance. So let's actually take a look at an example that I put together. So what we have here is a fictitious company that I call Teach IT, and they're in a business park. They have two different buildings that are separated across the business park parking lot. On the left, they have their training center where clients come in and they learn from them. And then over on the right, they have their executive offices where they need to connect the two together via a wireless connection. And in the executive offices, it's going to be a wired network, so we don't have any wireless here. However, in the training center, because all their students are going to be coming in with their own laptops, we need to have a wireless network. So what we've done in this example is in the training room, which we see up in the top, we have a omnidirectional antenna. It's a 5 dBi omnidirectional antenna. So our signals are going to go in all different directions for everybody in this training room. Now, what you're going to see down here is in the conference room, we have a unidirectional antenna, and it's on the wall, and that way it only radiates out this way into the conference room, so it doesn't go outside of the building. And then in the waiting room, we have another unidirectional as well for everybody sitting in the waiting room. Again, it only goes into the building. It doesn't go out of the building. And then the virtual training lounge, this one is going to be wired, so we don't have anything in there. Now, to connect the two different offices together, we have a 10 dBi unidirectional antenna on the roof of each building. And so this will allow these two to communicate back and forth. Now, you may be asking, how do I know what dBi I need? Well, that is where your site survey comes into play. You have to do a bit of testing and a little bit of experimenting with different antenna strengths. And then as you do some testing, some mocking up, you'll end up identifying the appropriate strength of antennas. So that's antenna selection and placement. Now let's take a look at network security considerations. So the last thing that we need to consider is network security. Network security in this day and age is vitally important to any network, whether it be a home network or a school network or a business network. We need to make sure that we have proper authentication and encryption measures in place, as well as other measures in place. Now, we're not going to talk about the specifics in this lecture because I'm dedicating the next lecture to network security, specifically as it pertains to wireless networks. But I did want to introduce it here because this lecture is all about the important factors that you need to think about when you're deploying a wireless network. So that's going to conclude this video. If you have any questions, please let me know. If not, thanks for watching, and I'll see you at the next video. Take care. Well, I hope that you enjoyed today's video and you learned a lot from it. If you did, please give this video a thumbs up and also consider subscribing to my YouTube channel. Now, if you're interested in taking this full course or just learning more about it, check out the video description down below because I've included a link where you can learn more about the course and enroll into it if you'd like. So again, thanks for watching my video. I appreciate it, and I look forward to seeing you guys at the next video. Take care.